Okay guys, now we'll be doing series. I like this way, series, because our YouTube channel the name of our tutorial project, it's Maths and Science series. Okay, T1, T2, T3, T4 is known as a what? As a sequence. But T1 plus T2 plus T3 plus T4 is known as a what? As a series, meaning that a series, it is the addition of the terms. I don't know if you understand that. So I'm going to take you to, actually I'm going to show you the 4 types of series that you are going to deal with throughout the grade 12 sequence and series. But we won't be doing sequence, we'll just do series. Because actually, today's lesson or the lesson on series for now or on this lesson, it will be showing you how to write the sigma notation and how to evaluate everything that's under sigma notation. But it's very important for you to know that we have I don't know why I'm writing this for. We have 4 different types of series or series. I don't think if we have the plural form of the word series. So I'm not sure if you know it, it's a good thing, we'll pass. Alright, now let me say we have 1 plus 3 plus 5 plus 9 plus 11. Then we have 1 plus 3 plus 5 plus 9 plus 11, then plus 2. Let me say 60 terms. Then we have 1 plus 3 plus 5 plus 9 plus 11 plus 60. Then 1 plus 3 plus 5 plus 9 plus 11 plus Okay, it's very important, guys, that you know how to differentiate these 4 series. Why I'm saying it's a series? Because the terms are being added to each other, or we summed the terms. So it's very important that when they give you this to write or to write it in a sigma notation, or to write this one in a sigma notation, or this one in a sigma notation. So it's very important because these 4 options are not the same. So here we have what? The first term, which is 1, and the last term is 11. Here, meaning that if we're asked to calculate the sum here, we will calculate the sum of 5 terms. We will calculate the sum of 5 terms, meaning that we will calculate all of these numbers. So here in this topic, they can ask you to calculate, or they give you a series like this, then they ask you to calculate the sum of the first 3 terms. It means that you're going to add 1, 3, and 5, then that will be your answer, because they ask you to calculate the sum of the first 3 terms. Or they can say calculate the sum of the last 2 terms, meaning that you have to add. The word sum means add or addition. You have to add 9 plus 11 if they ask you to calculate the sum of the last 2 terms. Okay, so here they added 3, they added 1, 3, 5 plus 9 plus 11. Now we know that the first term is what? It's 1, and the last term is 11. It's a straightforward series, meaning that you will be asked to calculate the sum of the 5 terms. Then here, the first term is 11, right? They added, it's 1. They added 1, 3, 5, 9, and 11. Then after 11, this addition sign tells us that after 11, there are other numbers that are added. So they added those numbers up to 60 terms, meaning that the number of terms in option 2, they are 60. I don't know if you understand that, but let me just explain this so you can understand option number 2. They added 1, they added 3, they added 5, they added 9, they added 11. Then they added whatever, or they added it's 13, they added those following numbers, they added those numbers, then the last term that they added, it's 60. This is the last term of all the terms that are added in option number 3. But when we check option number 2, here they didn't add 60, but they added all these terms. Then when they were counting that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 80, 50, 59, 60. They added 69, they added 60 terms. As here, they added how many terms? 1, 2, 3, 4, 5. They added 5 terms. But here they added how many terms? 60 terms. Then what about option number 3? The last term that they added, it's what? It's 60. It doesn't mean that here we are having 60 terms, no, but it means that the last term that is added, or the last term or the last digit that they added, is 60. So they can ask you to calculate what the number of terms, but you're going to see that as we are continuing. But here, if they ask you the number of terms, is that 60? I don't know if you understand that, but you'll see it. Meaning that if you are asked to calculate the number, the sum. You'll be asked to calculate the sum of 60 terms. Then here, you just do what? You take the last term, you equate it. Let me say this is an arithmetic series, as we're going to talk about those things, arithmetic series or arithmetic, or linear series. You're going to actually generate the formula here, then you take the last term and you substitute it where there's Tn, then you find the number of terms. Then here, number 4, but I'm going to show you this. Here, they added, 1, they added 3, they added 5, they added 9, they added 11. Then there's a plus there and these 3 dots. They're telling us that the number or the numbers that are added, they are continuing, or 11 is not the last 10. It is not the last 10 because this was a positive sign. It tells us that the number are continuing, or the numbers are continuing, or they are adding other numbers after 11, meaning that we do not have the last 10. So here we will be asked to calculate what? The sum to infinity. I hope you have seen this thing in your textbook or past question papers. Here you'll be asked to calculate the sum to infinity because these numbers, they don't end, they continue. So we have the last term, the first term, but we do not have the last term. Here we have the first term, we have the last term. Here we have the first term, but we don't have the last term. But it's you can do find the last term. Here we have the first term and the last term. So this is very important, guys. You're going to see this as we are continuing. Don't think that I'm boring you here as I'm doing this. It's very important. So these are actually fundamentals of the series. So it's very important for you to know these guys. As we are doing sigma notation, okay, there's a symbol which we are using to represent sigma. So this is known as sigma. It's actually a Greek alphabet. It's actually alphabet S, meaning sum. It's sum, meaning addition. To those who are doing physical sciences in momentum, there's sigma P before and sigma P after, meaning that the addition of the sigma before equals the addition of the sigma after. Or sigma EK before equals sigma EK after, to those who are doing physical sciences. Now, since they can give you what a series wanting you to represent or to write it in sigma notation, you will never be given something like this to represent it in a sigma. No, but if it is a series, that is when you are going to be asked to represent it in a sigma notation. So I'm going to take you to the lesson of sigma notation. Now here we have Tn. So the Tn, we know that in sequence we have Tn equals 8 plus n minus 1 D, we have Tn equals A n squared Bn plus C, Tn equals AR to the power n minus 1. So this is a linear, this is a quadratic, then this is an exponential or the geometry. So here it can be any of these patterns or sequences. Then here we're going to talk about this and that one there. But it is known as the top part, then this is known as the bottom part. Then the textbooks say that this is last and this is first. But let's use top and bottom. Let's just do an example, because what I was going to say there, you're not going to understand it. Okay, let me say you have the very same series 7. Okay, then they want you to represent this series in a sigma. So here, since it is a series, you can do what we can use that this symbol, since it is a sum, since they summed or they added the terms. Okay, for me to write the sigma, there are steps which I must follow. I must check if, or I must check the type of a series is this. Or actually the sigma thing, it is the continuation of grade 11 number pattern. So this is what I have to do. I have to check if this is quadratic or if it's this linear or geometric sequence. That's the first thing that you must do, because I said that here you put what? The general formula. It can be linear, it can be quadratic, it can be geometric. So 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 11 is 2. So that's what the linear sequence. Then we do that. So it will be 2, 2, 2, 2, 2. Remember, we know that this 2 is a common difference, right? Then we generate the general formula. It will be A plus n minus 1. You must show all of these steps. So what's the first term? It's A. N minus 1. Then D becomes 2. Then Tn is 1 plus 2n minus 2. Therefore, we have Tn as 2n minus 1, because 1 minus 2 is minus 1. Then what do we do here? We just draw this sigma symbol. Then here you put what? The general formula, which is 2n minus 1. What about this part and that part? We said that this is what? It is bottom, then that's what? That's last. Then the first term becomes bottom. Then this one becomes top. Meaning that for me to get the bottom answer here, I must do what? I must equate the first term with the general formula. Meaning that for me to get the bottom part, I have to say 2n minus 1 equals the first value or the first number, which is 1. 2n equals 2, because I'll take that 1 to that right hand side to become 2. For I divide and I divide, therefore n becomes 1. Then since this is the bottom part, or this answer belongs to the bottom part, I take it as it is, then I write it here. I don't know if you understood that. Meaning that for me to get the top part, I do the same thing. Top part, I have to do what? I have to equate this 11 to the general term, which is 11 equals 2n minus 1. Then we transpose this to the left, it will be 12 equals 2n. And 4 you divide by 2, you get your answer as 6 equals n. But here, remember, on the bottom part, we took everything. We took the answer and the n. We substituted it here on the bottom part. But this one, we only take the answer only, not the n, when we want to write the answer on the top part. So it will be 6 here. So you have represented it, or you have written it in a sigma notation. I don't know if you understand that. We will say that this represents the series. Why? Because we use this formula to represent all the sequences depending on the type of a sequence. But since we can see that there are additions here, not the commas, we continue. Since I said that the sigma thing is actually the continuation of what we know from grade 11. I don't know if you understand that, guys. So this is what the sigma notation. So this represents that. I don't know if you understand that. And you can be asked to calculate this thing. They say it's number of terms. So it's very important for you to know how to calculate the number of terms in a sigma notation. So here it's 6. It will be 6 equals n. 6 equals n. Then I took this 6 as I was explaining that for the bottom part, you do what? You take everything, you write it here. But for the upper part or the top part, you don't take the n, you only take the 6 or the answer and you write it there. Okay. Now they can ask you to calculate the number of terms. So the number of terms equals top minus bottom plus 1. So the top part is 6 minus bottom, which is 1, plus the 1. So this one is the actually this is the formula. So it will be 6 minus 1, it's 5. 5 plus 1, it's 6. Meaning that you have 6 terms here. We'll be asked to calculate the sum of 6 terms. Maybe someone will just ask me, why didn't I take this 6 since we got the number of terms as 6 there? It's not always that the answer or the answer that will be in the top part will always be the number of terms. What am I saying? What I'm saying is, let me say here we have n equals 0, then here it's 6 to n minus 1, then they want you to calculate what? The number of terms. Remember, top minus bottom, 6 minus 0 plus 1. So the answer here it will be 7, not that 6. It is not always the answer, it is not always the case that this top part will always be the number of terms. It will only be the number of terms if the n here is 1. But if it's not 1, make sure that you perform the calculation. So if it's, let me say we have 3n plus 6, n equals 4, then here they say 20. Then they want you to calculate the number of terms. You are not going to take that 20 saying that it's the number of terms. This is what we are going to do. You will say 20 minus 4 plus 1. Remember, top it's 20, then minus bottom, which is 4, plus 1. Then the answer will be 20 minus 4, which is 16. 16 plus 1, it's 17. So here we'll be asked to calculate the sum of 17 terms. But the most important thing, make sure that you start by finding the type of a sequence. I got that this actually it comes from a linear sequence. It can be geometric, it can be quadratic. So the most important thing is that for us to represent a series, we represent it on a sigma or sigma notation. They give you this second one, they want you to represent it in a sigma. The first thing that I must check if this is a plus. Sometimes they can give you negatives, it's fine. Okay, let me just represent it in a sigma notation. I have to check the type of a series of a sequence. You must show this 2 minus 4, 4 minus 2 is 2. 6 minus 8 is 2, 10 minus 8 is 2, 12 minus 10 is 2. Then this becomes D, then becomes A. Therefore Tn, so since the difference is common, or since we're having a common difference, it means that this is a linear number pattern. Or it works with a linear, remember it's a series, not a sequence. therefore Tn equals A, which is 2, is 1, the first term, n minus 1, then what's D? It's 2. Therefore Tn becomes 2 plus 2n minus 2. For our answer, it will be 2n. Remember, this represents the sequence, not the series. So for us to represent the series, we use what? Sigma. Since the question says that you must do what? You must represent this in the sigma notation. Remember here we write what? The general term. Then for the bottom part, we do what? We take the last term, the first term, and we equate it to the general term. Then we'll have our n as 1. Then you take it as it is, 1. And for the top part, you write 12 equals 2n. Actually, you take the last part and you equate it to the general term, then you look for n. So n becomes 6. Is it 6? Yes, it's 6. Therefore, you take this 6, not the n, you take the 6 and write it there. So this is what actually you have represented your series in a sigma notation. So if they ask you to calculate the number of terms, you say top minus bottom plus 1. So 6 minus 1 plus 1. It will be 6. And that's not always the case, as I told you on that first example. So it's very important, guys, for you to know this. It's very, very important. So it's not that you're going to get 1 all the time. It depends on the type of the series you'll be given. It depends, guys. Okay. 2 plus 4 plus 6 plus 8 plus 10 plus 2. 100 terms. Then they want you to represent this in a sigma notation. It's 2, 2, 2, 2, meaning that the general formula, it will be 2n, right? Then here, it's 2n, right? Then this is similar, or is one and the same thing as the one that we were doing. So n will be 1. Then what about here? What about there? So remember, for us to write n here, we're supposed to take the last term, right? But now we don't have the last term. How are we going to do that? Because this is the number of terms. It's actually n equals top minus bottom plus 1. Then what's n? This becomes the number of terms because they added these numbers up to 100 terms, meaning that we already have our n, but we don't have this part here. Now, 100 equals top minus bottom. We have bottom, which is minus 1 plus 1. Therefore, 100 becomes top plus 0. Then top, it's that 100. I don't know if you saw how I've done it. Meaning that, let me say, let us assume that we don't have the number of terms. It will be 100 minus 1 plus 1 to be 100. So this is how you are going to do it, because this is the second part or the second option of the series as I was explaining to you guys. Okay, I hope you are following. Let me just use the very same example. Plus 100. So the Tn is actually 2n, right? Then sigma, it will be 2n here. Then the bottom part, it's n equals 1. Because I'll say 2 equals n, 2n equals n, right? Therefore n equals 1. Then what about the last part? It's not that I'm going to take this 100 and put it here, because now we know that the last term being added is 100. So it will be n 200. 100 equals 2n, then n equals 50. But you don't take the n, remember, you take only the 50. Then if they ask you the number of terms, it will be 50 minus 1 plus 1, which is 50. So this is how we are doing it, guys. Let me just do one geometric one, so you will do it yourself. You just check past question papers or whatever textbook you are using to write the sigma of a geometric. So let's check. This 1 plus 3 it will be 4. 5 minus 1 will be 4. Remember, it will be here, it's either 4, it will be 1 minus 3. It will give us 4. Then we know that it's an arithmetic sequence. But actually this is come from an arithmetic sequence, but it is known as a series since the terms are added. A plus n minus 1 d. What is A? A is negative 3, n minus 1, then d is 4. Therefore Tn becomes negative 3 plus 4n minus 4. Therefore Tn is negative 3 minus 3, which is negative 7 plus 4n. You can write it like this: 4n minus 7. Now you take this Tn, you write it right here, and the bottom part, you know that you take the first term, you equate it to the general term, then it will be, remember, it will be minus 3 plus 7, which is 4, plus 4n. Divide by 4, you get n equals 1. You take it as it is, since it is the bottom part. Then the upper part, you know that the last term it is the last term that they added in your series. So it will be 330 equals 4n minus 7. Then it will be 320 equals 4n. Divide by 4, divide by 4. I don't know if it's 80. I'm not sure. So if it's not 80, it's that answer that you got in your calculator. You don't take the n, only take the 80, you write it here. I don't know if you understand that. So this is how you are doing the sigma notation. So the number of terms will be 80 minus 1 plus 1, which is 80. Okay guys, there are formulas that are under sigma, that thing that we were doing. So there are formulas that are under sigma, which we can use to continue the sigma thing, because they can give you something like this. They say calculate, then they give you maybe n equals 2, 3n plus 2. They want you to calculate here. So what is it that you'll be calculating? Meaning that the sigma continues. Actually, it has formulas that are under it. So these are the formulas that we're going to talk about here: the geometric series and the arithmetic series. We only have geometric series and arithmetic series, not the quadratic series, but they can give you a sigma having what here, the formula or the general term that represents the quadratic series, but you don't have its own formula, but I'm going to show you how to tackle it. Now, the geometric series and the arithmetic series. Let me write their formulas. So this is the formula for a geometric. This is R1 minus R, where A is the first term, 1 it's 1, R is the common ratio as we know, then N is the number of terms. Or you can write it like this: Sn equals A R to the power n minus 1 and R minus 1. It's one and the same thing. But this one is not equal to A R to the power n minus 1 over 1 minus R. So this is not the one. So if you started by R to the power n minus 1, here it must be R minus 1. You started by 1 minus R, it must be 1 minus R, even on the denominator. Then we come to an arithmetic series. Its formula is Sn n over 2 2a plus n minus 1d. Since this is a geometric series, it has the relationship with a geometric sequence. So since this is an arithmetic series, it has a relationship with arithmetic sequence. Or you can use this one, n over 2a plus l, where a is the first term and l is the last term. I hope your teachers told you that the last term represents the general formula, since arithmetic series has a relationship with an arithmetic sequence. Since I'm saying that a is the last term, meaning that the formula of an arithmetic sequence, it is also the last term of the series or of the pattern. So you use that when you prove these formulas. So your teachers are going to show you how to prove them. I'm not going to do that, but it's very important that you know how to prove those formulas. It's very important to know how to prove them. So suppose you are given something like this. It's 100, n equals 2, let me just write 1. Then here it's 3n plus 2. Then they want you to calculate. The first thing for you to do, or before you can calculate, you must know the value of a if this is what, or you must know the value of a, which is the first term. You must know the value of d, which is the common difference. If this is an arithmetic or linear, you must know the value of r if it's a geometric, right? You must know the value of n, which is the number of terms. So how am I going to get if this, how am I going to get the first term? I have to generate the series. Meaning that since I have the general term here, I can use that general term to get what? The series. So it will be 3n. When there's n, I put what? 1. So since it starts by 1, I will put 1 there. But if it was 2, I would start by putting 2, meaning that it will be 3, 1 plus 2. I will have what? 5 here as the first term, meaning that the first term is 5 plus, just generate 4. Just generate 4 terms. So the second one will be 3, 2 plus 2, which is 6 plus 2. It will give us 8. Plus 3, 3 plus 2. 9 plus 2, it's 11. It will give you 11. 3, 4 plus 2, 12 plus 2, it's 14. 14. So these are enough, so you can continue. We are not looking for a general term because we already have it. We want what? The first term, the common difference if it's an arithmetic, the r if it's geometry, and the last term, the number of terms. So we already have a, we are happy with that. So what type of a sequence or a series is this? It's a linear. Y was 8 minus 3, 3, and 3. So it's what? It's a linear. We have D. We are happy. We have D, meaning that it's not a geometry. But if it was, we didn't have the common difference here, we would divide the terms to get the common ratio. And if it's not that, we can get what? The quadratic. But we don't have the formula for quadratic. If it was quadratic, we're going to add all of the numbers, then that will be your answer. But now since it's geometric, since it's arithmetic, we have b. Now what's the value of n? It will be 100 minus 1 plus 1, which is 100. Therefore we can use the formula as n equals n over 2, 2a plus n minus 1 d. Therefore, we'll be calculating the sum of 100 terms. So it will be 100 equals 100 over 2. 2, what is the value of A? It's 5. Plus 100 minus 1. Then what's the value of D? It's 3. When you substitute the 3, then you just punch this on your calculator. So your calculator, it will give you 15,350 or 15,350. So the sum of the 100 terms will give us 15,350. So it's very important. When they want you to calculate, the first thing that you must do, you generate what? The series. And after that, you check which type of a series is this. Is this a geometric, an arithmetic, or a quadratic? Since we do not have the formula for a quadratic, we're going to generate these numbers from 1 to 100. You write all of them, then after that you add all of them. They're going to give you that number or that answer. Not this one, but I'm saying if it was a quadratic. Okay. So it's very important, guys. Even if they give you a geometric, opposite is true, you do the same thing. But now the difference will be that you are not dealing with an arithmetic. Or they can give you something like this: 1 plus 5, okay, plus 3 plus 5 plus 7 plus 9 plus 11. Then they add maybe, okay, let me just end here. Then they want you, they say calculate. So you check if this is what? It's a geometric or it's linear. So this minus that is 2, 2, 2, 2, and 2. So you can calculate the sum of 1, 2, 3, 4, 5, 6 terms. Let me just use the calculator. I want to show you something. 1 plus 3 plus 5 plus 7 plus 9 plus 11. The sum of the 6 terms is 36. Sum of 1, 2, 3, 4, 5, 6 is 36. So if I use this formula, it must give me that 36. I can use this one or I can use that other one. Why am I using this one? Because I can see the last term. So Sn, we don't have actually we have the first term, but we don't have the n. How are we going to get the n? We have to find first what the general formula. It will be Tn a plus n minus 1 d. Therefore Tn equals a plus n minus 1 2. Tn equals 2n minus 2, or here it's plus 1, therefore it will be Tn 2n minus 1. Remember in grade 2, there were those questions that they were saying that which term is equal to 11, for example. Then you do what? You will take that 11 and equate it to the general term to find the number of terms. So yes, since we know the last term, we're going to do what? We're going to equate it to the last term. It will be 2n minus 1 equals 11 to get the number of terms, meaning that here, okay, it's 2n, and it will be what? It will be 11, it will be 12, then we divide by 2, n equals 6, meaning that we have the number of terms, which is 6. It corresponds with this 1, 2, 3, 4, 5, 6. Therefore, we use this formula, then n over 2, a plus l. So even if you can use that other one, it's one and the same thing. But this one is more simplified because we already have what? The last term, which is 11. Let me just write it here. You know that when I add this using the calculator, it's sum of 6 terms, which is 36. Let me just write it here. N over 2, a plus l. For S, 6, right? Equals 6 over 2. What is the value of A? It's 1. 1 plus the last term is 11. For S6, you punch this in your calculator, you get 3 here, then here you get what? You get 12. For 3 times 12, it's 36. It's one and the same thing with that. Meaning that if you have a straightforward series, you can you can do what? You can add all of them. Even if you use the formula, you get the same answer as you did using the calculator. But if you are given a quadratic one, because they can give you a quadratic one, wanting you to do what? To calculate a sum. You just add all of them because you do not have that type of what's this? The formula. So let's see if we are using that other formula. But this one, use this one if you know the last term, since we know the last term, but here we don't know the last term. Okay, to 80 terms. We don't know the last term here. We are not going to use that one because we do not know the last term. Okay, so here it will be S 6 equals 6 over 2, 2, 1. Remember the A is 1 plus N, which is 6 minus 1. Then the D becomes 2. Then you punch this in your calculator. Let me use mine here. It will be 6 over 2, 2, 1 plus 6 minus 1, 2, which is 36. You see, it's one and the same thing. But this one is more simplified because you already have the last term. So this is the last part of our lesson. So make sure that you understand before you can approach the questions. And know those 4 options that I gave you in the beginning of the video. It's very important, guys, that you know those 4. Okay, I forgot this one. They can give you something like this, expecting you to calculate. They can say evaluate, calculate, or determine. For example, look. Since we are having an n here, it means that the general formula must contain the n. But here we don't have the m there, meaning that this must contain what? The m. So they are actually expressing that 6 as what? As the general formula. So how are we going to use this one? Because I don't know the general formula that looks like this. It means that since here we are having an m, since I made an example here, since here it's n, it means that the general formula must contain what? The n. Meaning that this 6 can be written like this, m to the power 0. You know that all the bases to the power 0, it's always 1. So it's 6 times 1, which is 6. So this thing can be written like that. Therefore, 6m to the power 0 is our general formula. Then they want us to do what? To calculate. So here it becomes 6m to the power 0. Meaning that if they give you a number here, then use this. So for example, they give you 100, then here it's k equals 1. The general formula will be 100k to the power 0. I don't know if you understand that. Then you can use it to generate what? The pattern or the sequence, the series. So here it will be 6m, we know that m is 1 to the power 0 plus 6, 2 to the power 0 plus 6, 3 to the power 0 plus 6, 4 to the power 0. Then you know that the sequence, the series is 6 plus 6 plus 6 plus 6, right? Therefore, 0, 0, 0. Then this is our A, and this is our D. We haven't come across the geometric one. I'll just do one, then after that I end the lesson. And it will be Tn equals A plus n minus 1 D. A is 6 plus n minus 1, then what's D? It's 0. And you punch this in your calculator. It is 6, right? That's our Tn. But actually, we're not calculating the Tn here. So we're proving that it is equivalent to that one. I hope you saw that, or you can see that. But here they want us to calculate. We saw that this is what? It's an arithmetic. We got our D and the A. Therefore, how many terms? 12 minus 1 plus 1 equals 12. We'll be calculating the sum of 12 terms. So it will be S n equals n over 2, 2a plus n minus 1 d. Therefore, it will be S12, 12 over 2, then 2, it's A, which is 6, plus 12 minus 1, D, which is 0. Then you're going to get your answer at 60, if I'm not mistaken. It will be 60. Let's just make sure if it's 60. But even if it's not 60, it's fine. Okay. Yeah, we've got to write the 1. Minus 1, 0. Oh, it gave me 72, not 60. Oh, it's 72. Doesn't matter. There's no one who's going to mark me. So even if it's geometric, guys, same thing applies. You generate the terms, the terms of the series, then you check, since we got D, if it's geometric, we're going to get R, then you use that other formula, not this one. So this is the last part of our lesson. So please guys, make sure that you subscribe, you like, share and comment. You like, share and comment. Even if you can just write, thank you, brother LT. Yeah, I appreciate that. Thank you guys.